Example 6. Given that fx equal to 1 plus e power of x, where x less than and equal to 0, x plus c over 3 minus x, where x more than 0 and less than and equal to 4, c, where x more than 4. A. Determine whether fx is continuous at x equal to a. B. Given that fx is discontinuous at x equal to 4, determine the values of c. So, we solve for the part A first, where we need to determine whether fx is continuous at x equal to 0. So, for the step 1, understand the problem. We need to determine the continuity of the function at a number. As we know, a function f is said to be continuous at x equal to a, provided the following conditions are satisfied. The first condition is fa is defined. Second condition, limit fx as x approaches a exists. The third condition, limit of fx as x approaches a equal to fa. Step 2, devise a plan. We need to check the continuity of the function at x equal to a based on the all condition. If one or more of the condition above fail to hold or not satisfied, then we will say that f has discontinuity at x equal to 0. So, we carry out the plan by check all of the condition when all of the condition above, when it fail one or more of the condition, we will say that function has a discontinuity at x equal to 0. Okay, so we rewrite the piecewise function and we check for the first condition, where the first condition is fa equal to, where fa is defined. So, in this question, a will replace by 0. So, f0 is equal to 1 plus e power of 0. So, the answer we got is 2. Thus, fx is defined. The second condition is we consider the two-sided limit to know that whether limit fx as x approaches a exists or not. The limit of fx as x approaches to 0 from the left, okay, the applicable formula is 1 plus e power of x. So we solve for this limit and we got the answer equal to 2. And then we solve the limit of fx as x approaches 0 from the right. And the applicable formula for the x approaches 0 from the right is x plus 6 over 3 minus x. And we solve this limit, we got the same answer is equal to 2. Then we can conclude that limit of fx as x approaches 0 from the left is equal limit of the function as x approaches 0 from the right, where limit fx as x approaches 0 is equal to 2. Thus, limit of function as x approaches 0 exists. Okay, we continue with the third condition, where limit fx as x approaches a is equal to fa. So from the condition 2 and condition 1, we know that limit of function as x approaches 0 is equal to f0. Okay, thus fx is continuous at x equal to 0. Since f0 equal to limit fx as x approaches 0. Therefore, fx is continuous at x equal to 0. So, to look back, when x equal to 0, the function given has satisfied all of the conditions to be continuous. Thus, prove that fx has continuity at x equal to 0. So, finish for part A. We move for the part B, where in the part B, the question is determine the value of C. We need to find the value of C, where given that fx is discontinuous at x equal to 4. We go for the step 1, which is understand the problem. We need to find the value of C as fx is discontinuous at x equal to 4. Step 2, devise a plan. As we know, a function f is said to be continuous at x equal to a provided the following conditions are satisfied. For the first condition, fa is defined. The second condition, limit fx as x approaches a exists. And the last condition is limit fx as x approaches a equal to fa. If one or more of the conditions above fail to hold or not satisfied, then we will say that f has discontinuity at x equal to a. Okay, I highlight one or more of the conditions above fail to hold or not satisfied. We will say that f has discontinuity. So we can use one of the conditions above to prove that fx is discontinuous at x equal to 4. Next, step 3, carry out the plan. Okay, this is the piecewise function. For this question, we need to find the value of C. Okay. To carry out the plan, we can use the second condition to check the continuity. So at x equal to 4, okay, we consider the two-sided limit. Okay, first we consider the limit fx as x approaches 4 from the leftwards. Okay, the applicable part of the formula as x approaches 4 from the left is x plus c over 3 minus x. Then we solve this limit and we got the answer -10. And then we calculate the limit fx as x approaches 4 from the right. The applicable part of the formula for limit fx as x approaches 4 from right is c. So, limit c as x approaches 4 from the right is equal to c. Since fx is discontinuous at x equal to 4, therefore c is not equal to -10. Step 4, look back. If c equal to -10, the limit fx as x approaches 4 from the left is equal to the limit fx as x approaches 4 from the right. Therefore, fx will be continuous at x equal to 4. So, prove that if c not equal to -10, fx will discontinuous at x equal to 4.